How's my volume now, Ram?
Yeah, much better.
Okay, cool.
Yes, giving me too many proposals. Good morning, good afternoon, good evening, everyone. We'll give it 2 more minutes to allow people to join, and then we'll get started soon. Hello everyone. Welcome to today's online event for Hack4dev. I am Dr. Joyful Mjuli. I'm with the International Astronomical Union's Office of Astronomy for Development, and I will be chairing today's session. We're very excited to have everyone join us today as we celebrate this huge milestone for Hackathons for Development. It's been a very interesting long year. This all started last year around this time, actually, when you started recruiting people who would be interested in hosting regional hackathons.
Yeah,
And
it
then
started in June.
yeah.
June
So
last year.
it's basically just over roughly a year.
Yeah.
So today we will basically give an overview of what the program was about, who was participating, and what outcomes came from it, and also possibly future plans of what we can expect next. So to get us started, I would like to invite Kevin Govender to tell us a bit and reflect on the inception of Hack4dev and where we are today. Kevin.
Will I speak through mine?
No, you can speak through this office.
Okay, thank you very much, everyone. Thanks, Joyful, and thanks everyone for being part of this. Like Joyful said, this is really a celebration. It's a culmination of many years of an idea. Much of this started years ago when Dr. Carolina Odman came up with the idea of Hack4dev as a whole. Thanks largely to Islam for bringing this all together. We are where we are today, and today we're here to celebrate this culmination of a concept. So all I want to do is sort of give you a big picture of what this concept is about. Hackathons, hacking has earned a bad reputation from all the Hollywood movies, and people think hacking, it's a bad thing, hacking into people's computers and things like that. But the principle of hacking is really about putting your mind into a problem and hammering at it, hacking at it until it's solved. And this doesn't necessarily mean that you're hacking in a bad way. What Hack4dev is, and what the principle of hackathons is really about people coming together from across the world, from across disciplines, and to put their minds together to try and tackle a common problem. A lot of this inspiration, I know, from where Carolina got the inspiration, is from the astronomy community, in particular the dot astronomy community, who started having hack days at their conferences. And these hack days turned into such a creative place where we can basically commit our skills, use the resources, the computing resources we have, and address the problem. And what all of you have done, the participants in this Hack4dev project, all the teams from around the world, you've really come together, put your minds together to solve this problem. And it really is an example of bringing like-minded people together and addressing big challenges in the world. And hopefully, as you will find out today, we want to grow this, we want to expand this, and continue to use the skills, the infrastructure from within the astronomy community, within the computer science community, technical skills that will help to solve the world's challenges and ultimately make the world a better place. So with that, thank you very much. I'll hand back to Joyful.
Thank you, Kevin. Before we get started, I love how we have so many people gathered here today. It would be great if we could all just see each other's face for like a few seconds. So I would like to ask everyone, if possible, to please switch on your camera and just wave so we can just see who we're working with. There's a lot of people that don't know each other. Some of the participants that were part of the regional hackathons don't know other people from different countries. So it would be just nice to sort of kind of see people's faces. Hi, everyone. So many faces. So many faces. It's so exciting.
Some faces might be in bed or or some people might be listening in.
Yeah, especially because we're all in different time zones. We try to accommodate as many of the regional hackathons participants as possible. So if you are in bed, it's okay. You don't feel the pressure to switch your camera on. We understand. But anyways, so just to move on with the program, so we can provide an opportunity for people to ask questions, to interact, and also share their experiences. We'll move on to the second part of the program, where Eslam will actually tell us a bit about the data science hackathon model and what future plans they have after this big milestone and how they plan on expanding.
Thanks, Joy, and hi, everyone. So, like Joy said, I'm Islam Hussein. I'm also, oh, sure. Thanks, Ron. So I'm Islam Hussein. I'm also the Hack4dev lead. I'm also a PhD student currently at the University of Leeds, where my work actually focuses on hackathons and how we can improve them, which is just what I've just going to show you now through the first implementation of the data science hackathon program. This program was delivered or getting implemented by several partners with like Brix Astronomy, the IDEA, Dara Big Data, and Athos. So today I'm going to speak about, through this talk, I'm going to speak about what is hackathons, Hack4dev, why we also use hackathons in general, some of the challenges that faces those hackathons, and the first and the data science hackathon program itself, and what is next for Hack4dev. So like Kevin mentioned, usually when I do mention about hackathons, two things come to mind. First is the illegal access of data, and the other is the kind of work that we do, which is collaborative events that is aimed at basically producing solutions to problems within a very short time. Those kind of hackathons are usually very popular amongst software engineers, but in our work today, we are mostly focused towards data science. So yeah, before speaking about the establishment of Hack4dev, I think it goes all the way back in 2018, or maybe before even that, and it's because of the square kilometer array. Several partners established several programs. Some of them are like hackathons, and the idea was to strengthen the big data capacity across Africa, and then moving forward now to May 2022, Pro Carolina Altman established Hack4dev, and actually it was at the OED. Kevin actually was the one who took the picture. And the idea was that she wanted to bring several collaborators together under a unified vision. And then moving forward now to the 10th of July, specifically 2025, this is where Hack4dev became independent. And the mission for Hack4dev is basically to design and deliver global scalable hackathon programs that is rooted in transdisciplinary research and expertise, with the idea or with the objective is to accelerate skills development and innovations. And we do have this kind of expertise for our data science hackathon program. We are working with people who have knowledge of hackathons, social science as well, data science, HPC, and operations. So, but why do we use hackathons? Why sectors, different organizations use hackathons? And there are sectors such as education, health, and industry. They usually struggle with even past. They even struggle with past industrial revolutions, and this is even more the case now with the fourth industrial revolution because the innovation rate is extremely high. This really gives you two big consequences. The first is the skill gap, which is basically the mismatch between industry needs and available expertise, but also you would have a slower rate of innovation. And the solution is that basically we use hackathon as an agile tool to accelerate development. Acceleration and development can either happening by accelerating skills development or finding solutions to current problems faster. And this is why in the last 20 years since the inceptions of hackathons, we have seen like its growth across many disciplines like education and health and data science. Now, when it comes to the challenges that faces hackathons, so there is a big limitation when it comes to hackathons, which is it has a very short time frame. It usually lasts from 1 to 3 days. And because of that, usually it just leads to innovative ideas and the early prototypes. And it rarely leads to deployable solutions. And like I said, this is because of its short time frame. And this is why people or organizations have incorporated hackathons into larger innovation process like the pictures that we have here on the right, where hackathons again leads to innovative ideas, and then those ideas can be developed further into fully innovative, fully developed solutions. However, from the literature, it actually shows that only 5% of those projects continue after the 5-month period. And this is even more also the case with data science solutions. And I would say there is a bigger reason behind all of that. Basically, people don't study hackathons. There's usually there is a big lack of hackathons research, and there's also a big limited knowledge exchange between hackathon researchers and practitioners. However, we don't really have this kind of limitations at Hack4dev, because not only we know how to implement hackathons, but we also study them, and we also critically analyze our own implemented hackathons and the one that also has been reported within the literature, which really brings you now to the data science hackathon program. The objective of this program is to use and develop data science skills to address global data science challenges. Okay, so this is the framework or the system that we used for our for the data science hackathon program. As any system, you would have input, and after the input, you need to design the system, or you design the hackathon event itself, and then after that you get to implement it. In our case, we had 2 stages in implementation, and at the very end, you will get your output. An input can be something like the hackathon challenge, the hackathon data science challenge, can be also the human capacity that you have, or the infrastructure, computational infrastructure. After that, you get to use this kind of input to design your own event. In our case, we use a novel model, a novel-based education model called the flipped classroom. But in our case, how we use it is that we give to the participants the resources and the hackathon challenge 2 weeks before the event itself. And then moving forward now to the implementation, we implemented the hackathons, like I said, over 2 stages. The first stage is through the organizers hackathon, and the idea, well, you get to train the hackathon organizers at this particular event, with the idea that they would need to go back to their own region so they can implement their own hackathons. And this brings me to the regional hackathons here. And after that, basically, you get your output, which is basically the solutions that you get from the teams on the submitted, from what they submitted. Okay, like I said, these are the 2, I think, most novel characteristics in our framework. The flipped classroom, the idea is that we use this so you can increase the quality of the solutions by giving them the resources, and the hackathon challenge basically give them more time to tackle the problem in their own time before they come to the hackathon itself, and the hackathon itself becomes like an environment where people just can work together to find unique solutions to solve the problem.
Do you want to take questions now or at the end?
No, I think at the end. And then we also use the hackathon cascade model, and it's basically the idea is that you want to increase the chances of attaining a novel deployable solution. So we try to increase the quality, but also we try to increase the chances of attaining a novel solution. So now this is now moving forward to the time frame that the time frame of the program. In June last year, we had the organizers call. At the end, we had 64 applications, 14, and we selected 14. In October last year, we had the organizers hackathon. It was held at WITS in South Africa with a 3-day structured program. And then from February to April this year, we had all regional hackathons implemented. And from May to August this year, we were busy with other things, but we were also busy with analyzing the 48 solutions that we got. Now, those are the resources that we actually gave them 2 weeks before the hackathon. First was the challenge notebooks. It had about, I think, 4 to 5 notebooks. The first notebook about introducing the challenge. The last notebook about evaluating how the participants can evaluate the problem. After the second resources we had was Prof. Thron's video. And the idea basically is that you get to introduce a challenge, and also from what he did, they also gave them research tips on how they can basically solve the problem. I think the video itself got a huge number of views. I think by the end of the regional hackathons in April, we got, I think, about 850 views, which is something, first time seeing something like that. And then also we gave them cloud computing introductory video, and this was done by Finis. He works currently at Elifo/IDEA. And we also gave them a Google introductory machine learning course, and this is the only thing that we did not develop. We just gave it as a resource if some of the participants wanted to felt like that they want to improve the machine learning skills. Now, this is some of the impact that we have, we had. We basically did have 13 hackathons implemented across 12 different countries in just 3 months. We also ended up training 50 plus organizers, and they helped us obviously to reach 150 plus participants, where they ended up developing the practical skills on a real data science challenge. We also, in just 3 days of intense collaborations, we had the teams ended up submitting 48 solutions. 20 of them ended up outperforming the baseline, with the best running solution is 106 times faster on the unseen data. It's basically this data, no regional hackathon get access to this data. And then yeah, to the also I think what is great also is that we are working on a data science paper in collaboration with the teams behind the 20 best solutions, but we're also working on an operations paper that's happening in collaboration with the organizing teams. Okay, so these are some of the graphs. We ended up having 121 respondents from all regional hackathons. The top graph here shows basically the number of people that went through the hackathon resources. 75% or up of the respondents basically went through Proctron Video, the Trend Notebooks, and Elifo Video. The pie chart here, the bottom left, we basically asked the participant how much time did they get to spend in reviewing the pre-event materials, and 55% of the respondents basically said that they spent 7 or more hours on the resources. On the right, bottom right here, we have the last graph on this slide, where we basically asked the participants to rate the hackathon, the resources basically, and 60 of the participants up basically said that they found the resources either being very or extremely helpful. More of the feedback that we got, we also asked the participants how encouraging the hackathon environment itself, like did it help them to think creatively and also to find unique ways of solving the problem? And the majority seems to agree, like strongly agree, and also agree. And we'll also ask them to rate how much they felt improved, or how much improvement that they felt feeling like in machine learning, teamwork, problem solving, and time management. And the majority also says they either found huge or significant improvement. And on the last graph here, also it shows that on the bottom right here, we asked them to rate the overall hackathon experience, and the majority gave like an extremely high rating. Before I continue, and I'm about to conclude now, obviously I would like to thank the organizing teams, because this kind of ratings is a testimony to their great work, really. It's yeah, we wouldn't have gotten this kind of feedback if it wasn't for the work that they did. Yeah, and I think now we are kind of now, I think I would like to conclude that we are kind of transforming hackathons. We are transforming the way people can use hackathons, and people can also perceive like what hackathons can do now. In the past, like I said, hackathons leads to innovative ideas, but in our side, hackathons now can lead to novel deployable solutions. Obviously, I would like to say like this kind of program will be tested further and further in the future. So we would like to see like what works and what doesn't work for us to be able to get this kind of results. Hopefully we will get it with every cycle. So now to conclude, why is it? Can you see? I think it's stuck here. I don't know.
The most important slide.
Yeah,
Right at the end.
I don't know. Should I stop sharing?
Stop sharing.
Yeah.
Oh,
Hey, there we go.
Funny.
Okay, well, guys, I'll just share again. Sorry about that. Okay, thanks for that. Yeah. Oh, So, to conclude now, we are planning to expand the number of hackathons that we are planning to do from 13. We are planning now to go to even 32 regional hackathons if the resources allows, because we do have funding, but it's currently very limited. The call for the organizers hackathons will be actually released like a few weeks from now, by the 30th of September 2025, and the next call for regional hackathons will be by the 1st of June 2026. And by that, I would like to end by that we are opening our hands for collaboration or for partners if they would like to contribute data science challenges, but also to fund some of the programs. We also have other programs beside the data science hackathon program. And we also, if they would be willing to provide resources like computational resources. Okay, so now I'm at the end. I would like again to thank our partners and also would like to thank our regional organizers. And at the end, I would like to thank our participants. They are the reason why we are doing all of this great work. And also usually hackathons require courage, some courage for people to apply for. And I'm really grateful for all of them. So thanks. Back to you, Joy.
Well done.
Thank you, Esam. That was very insightful. It's the first time I actually also see all of the work that went into this. So it's quite impressive that you managed to pull this off in just less than a year.
No, thank you.
Yeah, I know. That was really very impressive. I'm just like still trying to process all of the things that you showed you showed us recently. But yeah, congratulations.
No,
and
thank you.
we're looking forward to your 32 hackathons that are coming up next.
Yeah.
I imagine it'll be twice as much work, or do you have like a whole structure figured out that it will be less work?
We have round now, but the idea is that we need to approach it a little bit more careful on how we can automate the process more even than last year.
Okay, so if people want to like read about all of this that you just shared, is there going to be a place where you've placed all of these findings from your presentation? On
There are two publications, like I said, like there will be an operations paper, but also the data science hackathon paper, and it will have two aspects and two different papers. So I'm sure most of things will be shared by then.
Okay, fantastic.
Yeah. There's a question from Kelly.
Oh no, she said that it was just a mistake. It was not meant to be there. But if anyone does have a question for Islam about the presentation he just gave us, please feel free to raise your hand or just leave a question in the chat. And thank you to everyone who's so far been introducing themselves and also telling us where they're from and which part of the world they're from. It's very nice to see that we have a diverse crowd that has joined us today. I hope some of the people have been participants of the hackathons, but also some are just here because they're interested in on the Hack4dev program. But Josh, Kenny says that this work is very exciting. So she didn't have a question, but yeah.
Thank you.
Okay, and then so Eslam did mention that there was a CubeSat problem that was being solved, and it did better than the baseline study and survey that was done. So Ezra Fielding will actually tell us a bit more about the problem that was being solved for this hackathon challenge, and what makes everyone else's solutions better than the actual published data. So Ezra, you'll have to show Ezra's face.
Yes.
He doesn't have a camera.
Unfortunately, I don't have a camera on my
Eslam, don't push
laptop.
the laptop.
If you can see the OAD office, I'm waving. Hello, everyone. Now I'm on Islam's screen.
Multiple.
Yeah. So for everyone watching at home, please pick the best angle. I quite like this way, but it's up to you. Hello, everyone. My name's Ezra Fielding, and it's really great to be here. I'm a doctoral researcher at CNES, the French space agency, but I'm actually born and raised in Cape Town, so it's good to be home. It's good to be in this office. I'd like to start off by saying thank you so much to the Hack4dev team for actually just taking interest in our work. For those of you who participated in this hackathon and you actually sifted through all the documents that were sent out like you were supposed to, you would have seen an academic paper there that this work was based on. And I was fortunate enough to co-author that paper with now Dr. Keenan Chater at the Kyushu Institute of Technology. So like just from that perspective, it's really, really great seeing all these people from all over the world and the reach that our work now has. And it's no longer just our problem anymore, it's your problem too. So it's really great to see that. So what I hope to do with this presentation is just to give a broad outline on what a CubeSat is, what the problem is we're facing, and how we attempted to solve it, and then bringing that to how we converted that into a hackathon challenge. So without further ado, what is a CubeSat? I'm sure many of you may not be too familiar. The CubeSat is this cute little cube on the side that's 10 centimeters by 10 centimeters by 10 centimeters. So that is considered one unit for CubeSat. And it's essentially a class of nanosatellite developed around the concept of providing small, low construction cost, low launch cost space experiment platforms. So for that reason, it's been very, very popular with universities and for other educational programs. But on top of that as well, businesses and new space companies are starting to see that this small form factor, along with commercial off-the-shelf components, is allowing us to actually develop things really quickly and really cheaply that we can actually launch into space and produce real science with. So before, a lot of research has gone into verifying that CubeSats as a platform can work. And now you'll find that many new CubeSat missions are trying to do real science, and that's really, really exciting. But if these cute little cubes were perfect, we wouldn't have a hackathon. And we have a bit of a problem that's coming out. And it's almost because they're getting too good. So what we're finding is that CubeSat mission complexity is increasing over time. And quite simply, it's due to improvements in mission payloads. In the same way that your phone gets better year after year, the sensors we can send into space get better year after year, sometimes month after month. And that's resulting in dramatic increases in both the quality and the quantity of data being produced by nanosatellites in orbit. If you have a look at how much data it costs you to send an image via WhatsApp, because they're really high quality and you can hit the HD button, the even higher quality. In the same way, we have that same thing happening now with CubeSats. We want to make sure that we get this quality data down, but it's getting really, really difficult. And that's specifically because of major constraints and limitations that are placed on power generation, onboard computing, and data downlink capabilities. So to break it down, once again, 10 centimeters by 10 centimeters by 10 centimeters for 1 U of CubeSat space. That is not much space to put in batteries, computing power, communications equipment, and we have to place limitations in order to make it possible. So in terms of power generation, you only have so much surface to actually generate power with solar cells, and those solar cells themselves have a certain amount of power they can produce. Onboard computing, we need to make sure that we have small chips on these things, but at the same time, we need to make sure that they are not consuming more power than we are taking in. And then finally, and most importantly, almost to a hackathon like this, is data downlink capabilities of nanosatellites. So on many 1U nanosatellites, the downlink capability is equivalent to almost dial-up speed. So for those of you that are possibly too young enough to know what that means, we used to connect to the internet via a plain old telephone line. And we would essentially send data via audio. It would sound like this whooshing sound. We kind of do the same thing for nanosatellites, except we're on the ground and they're in space. There are better improvements over time, but we get to this point where we're kind of limited by factors of physics on how much data we can get down in a certain amount of time. And to give now some context around the paper that we wrote, the first author, Dr. Keelan Chater, and I, we were working at Kyushu Institute of Technology on the Vertex nanosatellite project. For all the astronomers that might be here, I'm sure you might be interested in this mission. We were looking to observe extragalactic background light, this time with a 6U nanosatellite. And we want to observe the EBL specifically in the visible wavelength. The problem with the mission is that it will produce a very, very large amount of data. What's cool is that we've seen in the literature that CubeSats are emerging as significant advancements in space-based telescopes, but we still have the issues that remain around something this small, this far away from us. So to give some more context, the Vertex nanosatellite, there's a nice little 3D render over here. It should be launching in financial year 2025 if all goes well. But that's a 6U CubeSat. So that's 6 1U sizes put together. And we're building it on top of the Bird's bus. We're now creating the Vertex bus, which is like an upgrade of the Bird's bus, which we have at QTech. And what I want to draw particular interest to is the payload. We have a custom telescope and a camera module that features a monochrome Sony IMX533 sensor. Really nice sensor, and we're looking forward to using this in space. The issue is that per frame, so per image, it is 17.23 megabytes of data, and we need all of that data. We are trying to look at background light, so not point sources, background light. So we can't compress and risk losing anything. So we need to downlink somehow all 17.23 megabytes. But in order for the study to actually be of use, we need to hit a certain target of the night sky. And what that translates to, at least from the engineering side, is that we need to downlink 689 megabytes of data per day. We are taking enough images in orbit per day to generate 689 megabytes. That's actually quite a bit of data, even on the ground. And to give you some context, at the time of writing the paper, we were trying our best to get to 5 megabits per second downlink. We managed through some technical wizardry to get 10 megabits per second. But if you are trying to do, you can do the math on your side. If you try to do 10 megabits per second, but you only have 10 minutes twice a day to downlink these things, you need a way to maximize scientific data so that you get the most useful data down to you first. So that's what we tried doing with this paper. So like I said, some of you should be familiar with this paper. So the data downlink prioritization using image classification on board a 6U CubeSat. We published this in an SBIE conference. And the aim really simply is just to reduce the burden on data downlink by creating an on-orbit pipeline to autonomously classify and compress desirable image data for downlink prioritization and optimization. We're living in an amazing time where machines can learn and intelligence is now artificial. So in that world, how can we take something that can fit on this resource-constrained environment, put it on orbit, and have the satellite decide what is the most useful images from a scientific standpoint, or whatever standpoint we define, and how can we get those to the ground first? So hence we're trying to do a pipeline. In the paper, we looked at two approaches which we combined. So the first part was machine learning to prioritize images. We need to figure out which images are priority to send down. But also we tried looking at some lossless image compression, which is pretty cool, but it's not quite applicable for this hackathon, so I won't go into that part. And most importantly, we designed this to run on real satellite hardware. It doesn't make sense that we're doing a paper, but then you need a supercomputer to run this. So as part of the Vertex project, I was responsible for the Vertex camera control board. And that is basically just a Raspberry Pi compute module for carrier board. So if it can run on an 8 gigabyte of RAM Raspberry Pi, we believe that it can run in space because we've factored our power budget and everything else accordingly. So with it, Dr. Keenan Chater put together a classification data set. There are 5 classes: blurry, corrupt, missing data, noisy, and then of course, importantly, the priority data set. The idea is that you want priority sent down to the ground first, because that will be the highest amount of scientific value. Why we have the 4 other classes? Well, perhaps you want to add some further automation in the future. If you have noisy data or corrupt data, you could have the satellite perhaps autonomously recapturing it. And then also perhaps you've downlinked all of your priority data, so you want the next best thing, so then you can rank those accordingly. You can do what you want with it. So that resulted in about 20,234 images in total. We augmented the data in certain ways. You're welcome to look at the paper to figure out how we did that specifically. And I should note that the source here is the SDSS 16 survey. So unfortunately, Vertex wasn't launched. So at the time of when we wrote this and when we did the testing, so the idea was, how can we take images that should be like what we get from Vertex? So that pointed us to SDSS 16 survey, and we cropped and chopped and changed those images to do what we need to do to make it indicative of what we'd find with Vertex, more or less. And then, of course, the data set itself has a 80-20 test train split. But also, I know for the hackathon side of things, we further split the test data set so that we could have an unseen data set for evaluation later. So you can figure out how everything was set over there. Now the baseline solution. So in the paper, we offer a solution to this problem. And for the hackathon, it's turned into the baseline solution. It's a convolutional neural network based off of the CubeSat-Net convolutional neural network, which also actually came from QTech. And the idea is that we can put these images in and then we can classify them to the 5 classes. It's supposed to be nice and compact and small so it can fit on these resource constrained systems that you get in CubeSats. And it ended up performing very well, almost too well if you ask me, because it would have perfect or near perfect classifications for all classes in the original paper. So that leads you to ask the question, how do you turn this into a challenge? If our model was essentially giving 100%, if you account for rounding, 100% accuracy, how do you let people work on this and improve it? Well, in the world of CubeSats, accuracy is not everything. I'll remind you that CubeSats provide a heavily resource-constrained environment, whether it's the amount of power the CPU has, whether it's the amount of electricity stored in the batteries or the power produced by the solar cells, also with the amount of data that can be downlinked. So where we can find improvement is not necessarily accuracy. Accuracy can be good enough, but in this case, what we want is we want more efficient solutions. How can we make it so that the least amount of CPU time, the least amount of energy is being consumed? And that is where the challenge for this hackathon came around. So that informed the way we evaluated the solutions. So among all of the solutions, achieving at least 99% accuracy, chosen arbitrarily because that's good enough for our use case, it's good enough for this mission, and using less than 13,000 megabytes of memory, in this case chosen because that's the amount of memory that the baseline used on our test system, the winner will be selected based on the lowest total runtime, as this corresponds to the amount of power that will be used. So the thinking is that if you are spending less time running an algorithm, less power overall will be used. Of course, there's caveats, and if the mission was slightly different, we'd probably maybe looking more at memory footprint. Perhaps also if you wanted to use less of your CPU, but you had other things to do, we would have asked to use less CPU time. But at the end of the day, for this mission and for the mission that we set out to accomplish in the original paper, this is the way we evaluated it. So to once again, just hammer it home, among solutions achieving at least 99% accuracy and using less than 13,000 megabytes of memory, the winner will be selected based on the lowest total runtime, as this corresponds to the amount of power that will be used. Also should note that, unfortunately, we weren't at the stage where we could ship out 8 gigabyte Raspberry Pi 4s to everyone and have enough for every hackathon. So working with our partners at Ilifu, we provided them with the platform, but we limited them to 1 CPU core. Essentially, that's we're trying to mimic the CubeSat CPU resource constraint, but also at the same time, all evaluation is done apples to apples as close as possible. And what I mean by this is that we've rerun the baseline, or should I say Islam, reran the baseline on the identical platform to what was used for the hackathon, and all evaluation will be done on that. So some types of solutions received. It was very cool seeing something that you worked on and looking at other people's take, and also understanding that their take on it was also done under immense time pressure, and I salute each and every one of the participants. But what's really cool is we had deep and non-deep learning approaches. So in the original paper, we used a convolutional neural network, but we also saw things like random forest, logistic regression, stochastic gradient descent, and linear support vector machines. I was very interested in especially the non-deep learning approaches, just because that's something that we didn't even consider in the original paper. And also on top of that, various pre-processing methods were used. So it's not, while we didn't use any pre-processing, we just said, okay, we'll just stick it into this. Some of you guys were much more smarter about this and decided to pre-process, and that fed into the overall result at the end. So that leads me to something that I'm very happy to announce.
Drum roll.
Drum roll. Considering the requirements for this challenge and one thing I just really want to hammer home before I move forward is that space is really about the mission. A solution that could be the best solution for one mission might be an okay solution for another mission. So please don't feel too bad. We chose it based off of this challenge, based off of this mission we defined. Considering the requirements for this challenge, the best solution was provided by Team 6 from Madagascar. Woo!
Yay!
So big congratulations. I hope everyone, wherever you may be in the world, that you're just giving a nice round of applause. I can see all of the emoji bursting up. So very, very exciting. I really do want to hand over to this team so they can discuss their solution very shortly. But I need to add just a few cents over here. So I just want to point you to this graph where ignore the label. This is Team 6 from Madagascar in the lower left-hand corner. And what you'll see here is that they took the least amount of time, but they also had the lowest amount of parameters. And that's usually a good indicator for also how large the model will be, how much space and memory it will take, how complex it is, if you will. And it provided a sufficient amount of accuracy for the sake of this mission. So I was very, very impressed and very, very surprised to see that they managed to eke out this type of performance with a convolutional neural network. In this table, you'll see the solution compared to the baseline, where, being totally frank and transparent, we just wanted to get a baseline out there. And the whole idea of when we wrote this paper was that people will improve on this baseline. So I know Islam mentioned a 165 time improvement. You see that very clearly here where our baseline took 445.48 seconds to complete. Meanwhile, Team 6 from Madagascar, their solution took 2.68 seconds.
Wow.
Which is really great. If you imagine that this is the amount of time that the Raspberry Pi needs to be on, if you're assuming about 3 watts power draw for Raspberry Pi, the only having that on for 2.68 seconds consumes a lot less power. So if I had to fly something today, it would be the solution from Team 6. So very well done. You can also see all of the other metrics. We do eke out a little bit more in accuracy and F1 score. I just need to say that. But I mean, when you're talking 99.1% accuracy versus 99.8% accuracy, at this point, I mean, we're just playing for peanuts.
How long
So,
did it take you guys to get to this baseline?
so this was probably a good 6 months worth of work.
They did in 3 days.
And they did it in 3 days. Yeah. So just remember, for any budding academics out there, you can do some really good work on a paper and be really excited about your results, but then somebody can come along and do it better in 3 days.
Now, what we also give them, remember, we give them also the challenge and resources before, like 2 weeks before the hackathon. So
Still doesn't fit
Yeah.
6 months.
I like to think that you stood on the shoulders of giants. Let's say that. So just for academic completeness, all the references that I've used. But once again, thank you so much to the Hack4dev team, to the participants. Thank you for finding interest in our work and for improving this. If you have any questions, feel free to reach out to me there's my email on the screen. I'm on LinkedIn. I think I'm the only Ezra Fielding, so you'll find me. But once again, thank you all. Well done to all of the teams, and especially Team 6 from Madagascar. Thank you very much.
Thank you, Ezra. So we have a recording from the team. They decided to put a recording together. You have it, right? You're looking at me funny. I think Raul played for us, so we can hear from Team 6. I don't know if they actually joined on Zoom, but we do.
Ask them to show their face.
Yeah, if Team 6 members from Madagascar are connected, please just turn on your cameras so we can see everyone. But there is a recording from the team to just basically give us.
There we go.
Yeah,
Anthony.
we have one face over there. Spotlight. Yes, it's spotlight him. You are in the spotlight. Wait, congratulations. Ram, maybe you can prepare the video. Oh, here's another face. I see another face.
Oh, Jennifer.
There we go. Add spotlight. Now there's two faces. Congratulations and well done.
Ah, there's another one.
There's another one.
Let's.
Okay.
Did you find this?
I'll keep adding. Yeah.
Okay. Two women. Okay. While everyone else is still switching on the camera, maybe I should just give a list of all of the other countries that were involved, because Islam just said 12 different countries, but didn't mention them. So the countries that were part of the hackathons, the regional hackathons, there were 2 in Kenya, Ghana, Ethiopia, Botswana, South Africa, Madagascar, Rwanda, Namibia, Mozambique, India, Brazil, and Chile. So congratulations to Team Madagascar for producing the best solution.
Hey.
Thank you.
Thank you, everyone. Ram, if you could please play the video. Still switching on the camera, maybe I should just give a list of all of the other countries that were involved, because Islam said 12 different countries, but didn't mention them. So the countries that were part of the hackathons, the regional hackathons, there were 2 in Kenya, Ghana, Ethiopia, Botswana. It's super delayed.
It's the time.
Okay, I think that should be fine.
A data scientist student at TIT Anjalmin and a member of the Group 6 from Madagascar.
Hello everyone, I'm Anthony and I'm a software engineering student at the IT University Madagascar. So nice to meet you all.
Hi everyone, my name is Hiro and I'm studying data governance and engineering at IANF Inahatsu, Madagascar. After the organizers assigned us to a team based on our skill levels, we introduced ourselves. We shared our names, studies, data science skills, and how we prepared for the hackathon. This helped us understand each other's strengths and assign tasks effectively. Next, we clarified the problem and made a plan for the 2.5 days of a challenge. We worked in 2-hour blocks, and before each block, we discussed tasks, and after each block, we shared progress, solved problems, and made team decisions. This approach kept us aligned and improved our solution continuously.
We explored multiple approaches from classical machine learning to deep learning based approaches, and after a few experimentations we deduced that regardless of the algorithm, the main bottleneck from achieving high speed and high accuracy with high efficiency was the pre-processing step, because it very often takes a lot of calculations, especially in machine learning based approaches. As a result, we opt out for deep learning based approach because it requires little to no pre-processing at all. And for example, the base deep learning model uses no pre-processing and still is very efficient and very fast. So we based ourselves on this model and made some adjustments. And the first adjustment we made was to add a little pre-processing step to reduce the size of the image from 516 to 42 by 42, which reduced the computations by a lot. And then we removed some layers from the convolutional layers, from 11 layers to 5 layers, because the shapes of the images, the shapes of the stars are quite simple. They are round shapes, not very complicated. So we knew we could afford to have less layers. And last but not least, in order to increase the speed, we changed the convolutional layers of the first layers into separable convolutions, which increases by a lot the speed of the algorithm without losing too much accuracy. And that is how we achieved our
So now let's talk about the results of our model. For the competition, our goal was to classify correctly the priority images while using minimal resources, which is a critical requirement for a model deployed on a CubeSat. We've successfully developed a lightweight image classification model that meets these strict requirements. The model achieved an accuracy of 98.9% while maintaining an extremely low resource footprint with a model size of just 0.06 megabyte. Most impressively, our model is 300 times faster than the CNN baseline model. The results highlight our ability to provide a solution that is both highly accurate and perfectly suited for the constraint of a CubeSat mission.
As my first ever data science hackathon, I'd like to say that not only was it very well organized, but also very fun. And for me, it was an occasion to meet people from various backgrounds, from computer science to astrophysics. And I really invite people to participate in those data science hackathons to upskill, especially this one. And I'm looking forward myself to partake in some ways in the organization of the next one, because we really need hackathons like this. And thank you Hack4dev for the opportunity. Thanks.
I really enjoyed this hackathon, especially since data science hackathons are quite rare in Madagascar. Being around so many passionate people was very inspiring. I learned a lot from my teammates, especially how to choose the right model parameters and why. This was also my first time speaking in public and giving a pitch in English, which was a little scary, but overall it was a great experience.
Before I finish, I'd like to share about my personal experiences with this competition. It was a huge step for me as a data scientist in training because it was my very first data science hackathon and also my very first time speaking publicly in English. It was a fantastic experience because I discovered that the skills that I've been learning were directly applicable, and it was incredibly rewarding to work with a team of people that share the same passion for the data as me. I'm proud of what we accomplished. It goes to show what a team of strangers, driven by a shared passion, can accomplish.
Finally, we would like to thank IDIA, Dara, and Hack4dev for making this hackathon possible. Thanks also to Astropulse for bringing this event to Madagascar, and Action Group for their support. And of course, thanks to all participants and contributors for making this event a success.
Very glad.
Thank you.
Yay!
Congratulations. I just want to add as well that the prize to the winners is sponsored by Dara. So Emma Smith is actually connected. So thank you on behalf of the whole team. Thank you to Dara for sponsoring the prize for the winning team. Maybe you can say something, Emma. Yes, please.
Hi, yeah, just really quickly, I put it in the chat, but just to say amazing work by everyone. And it was so nice to hear, especially from Team 6, about your experiences, how it all went for you. And just really thank you for sharing, and thank you to everyone and all the effort you've put in to make this happen. It's really great to see the results.
Thank you so much, Emma. Okay, so like everyone mentioned, and they thanked that the organizing team also played a key role. Esther mentioned it, but then also the participants thanked the organizing team. We would also like to acknowledge the best organizing team. I mean, I feel like everyone did a wonderful job because you've had 13 regional hackathons, but apparently there should be one winner. So I'd like to invite Nikita to maybe announce our best organizing team and also give us context on how you went about choosing this team.
Okay, thanks, Joyful. All right, hi everyone. My name is Nikita Ramkilawan, and I was part of the operations team, so working on implementing this data science hackathon program with Islam. I'm also working on the Dara Big Data Capacity Development Working Project. So that's also part of this. But yeah, so I just want to say first, yeah, this is amazing. Congratulations again to Team 6 from Madagascar. And of course, to everyone who's participated. It's so amazing to see, you know, like Joy said, it's been since, you know, early last year when we started working on this. So it's wonderful to see what's come out of it. So obviously, we want to thank our first cohort of these organizing teams. So thank you to the team leads, the organizing teams, and anyone who may have contributed in any way to making those regional hackathons a success. Everybody did this on a voluntary basis on top of their existing responsibilities. So just huge thank you to everyone. You know, we hoped that, of course, it would benefit the hackathon participants, but we also hoped that it would be an opportunity for growth and learning for the organizing teams themselves. And from a lot of the feedback we got from the teams and from interviews with them, it was clear that this has been the case. So I'm really glad to see that. And then lastly, this model, so on top of obviously, you know, building skills and driving innovation in these creative ways, it's also about building community. So thank you to all the organizing teams for the role that you've played in sort of strengthening this network and being this first cohort. And I hope there'll be lots more, of course. So let's talk about the metrics that we used. There's so much that goes into organizing a hackathon. I'm sure any of the team leads would be happy to talk about it for ages. But so the metrics we looked at was firstly communication with Hack4dev. You know, the operations team is there to provide support. We provide resources, and of course we host the organizers hackathon, where we introduced them to a lot of the aspects in terms of logistics, as well as taking them through the challenge itself. So they actually worked on the challenge in teams, similar to how the participants would in their regional hackathon. So we look at communication, we look at, you know, the timely execution of the event, not easy always, lots of circumstances come up. Recruitment and suitability of the participants, so that involves their, you know, marketing of the event, their social media efforts, also budgeting, how they, you know, manage that, and their financial prudence. And it's very important to mention that this choice of the selection of the best organizing team has nothing to do with the technical outcome. So we didn't include that at all when selecting the best organizing team. We just looked at the metrics I've mentioned. And do we need another drum roll? Okay. Yeah, so based on all of these things and a lot of discussion between the various members of the Hack4dev operations team, the award for the best organizing team goes to Madagascar.
Madagascar. They're dominating. They're
Yeah, dominating, totally. I mean, like I reiterate. Yeah, so that's why I had to mention that the two awards are completely unrelated. Just happens to be that way. Let me just say the prize. So this is funded by the OAD. So thank you so much to the Office of Astronomy for Development. Each member of the organizing team will receive a 3-month Audible subscription where you can stream all their content and then also purchase a few audiobooks and things like that. So that's from the OED, and thank you so much. So I'll hand it over now to Nyando, the team lead for the Madagascar organizing team, to say a few words.
Hello, everyone. I'm really happy that it turns out that, yeah, we won as the best organizing team. First of all, we were motivated to host Hack4dev Madagascar to showcase the country's potential in data science and also to create a platform where local talent could connect each other, So it was about giving young people the opportunity to solve real-world challenges such as the CubeSat, and we would like also to contribute to Africa's involvement in the field of AI. So I guess that, yeah, it's a very long story, but we're going to make it short. It begins with I think that the basis, the foundation is teamwork and clear communication, and it all goes from that. And sometimes we are trying to identify some problem because some problems arise sometimes, especially during the transfer of the fund from South Africa to Madagascar. We encountered some problems, which led to the delay of our hackathon, and hopefully it was sorted out. But apart from that, one of the major problems that we encountered is in Madagascar. We often have power cuts, and uh, the 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 venue at the university doesn't have like a generator, like a backup generator. So we have to find out how should we solve that problem. So we were trying to solve this by finding a local partner in Madagascar who has a very nice venue, the Axian Group. So they provided a venue for the opening and the closing ceremony, the venue where the participants come every day for the hackathon, and they provided also internet connection, very high speed internet connection. So most importantly, ahead of that, as most importantly, we created an inclusive environment where every participant felt supported and motivated. During this hackathon, every step was a learning step. So we were facing many challenges. First, as English is not our first or nor our second language. So we have identified that some of the participants they have encountered some hardship, like speaking English, understanding some the materials, but at the during the final presentation, we were really happy that all of them managed to present in English publicly. One of the challenges that we were facing also is where should we have like a very nice speaker? Yeah, there are a lot of speaker, but we like to pick one speaker that stands out, the mentors, the judges. But when we brainstorm with the team, we converges to a solution, and yeah, everything was sorted out. Regarding this award as the best organizing team, this award is deeply meaningful because it recognizes not only our efforts to organize, but also Madagascar's growing role in Africa's innovation system. It highlights the power of collaboration and resilience, and it shows that Madagascar can stand out proudly on continental stage. And yeah, I would like to conclude my message by for like a simple message for future organizers and future participants maybe that yeah, teamwork is the key. And it seems, yeah, let me borrow the quote from Nelson Mandela, that it seems impossible until it's done. So this happened to us, and I'm really happy. I would like to thank all the organizers, especially mentoring from Hack4dev, from Islam, Nikita, Zodwa, Joyful, everyone, and the support from the EDIA as well, from Tinus, because I guess that every regional hackathon face sometimes like the server were killed, so we have to run up to Tinus. Okay, can you fix that for us, please? Because some of the teams could not run and notebook. They killed the server. Yeah, I would also like to thank Dara for the support, FS, and everyone who contributed to that hackathon. Thank you. I think that's all from my side. Thank you.
Done.
Congratulations. Thank you so much for the message, Nai. I mean, I think you highlighted one very important thing that we probably didn't consider in the beginning of this whole thing, language barrier. So how can we make this more accessible for people who don't actually speak English as a first language? So something to like note down is for future hackathons and programs. How can you make it more accessible so that everyone can participate in this?
Sure.
Yeah. But otherwise, congratulations to you and the whole team. I feel like some of the people who were part of the Hack4dev organizing team are here with us. You just like hiding there at the back, guys. Can you come closer and wave at everyone so they can see your faces?
Okay.
I mean, they mentioned Zodwa multiple times. Here's Zodwa over here.
Let's give everyone a hand.
Even the team as well, like they in the office. I feel like you remove me as a spotlight and then everyone else can be seen. But yeah, congratulations to everyone who's part of this for making a success out of this. It's been a very interesting journey. Mostly from my side, I was just watching you guys just run around like headless chickens. But yeah, you guys pulled off something very amazing. We're looking forward to many more of this. We hope that everyone else who was part of this will then share their experiences with other people so they can also get to experience this. And also those who are interested in being part of this should be on the lookout for future updates that will be coming up soon. So Hack4dev is on all social media platforms. You can follow them on Instagram, X, Facebook. I'm going to list them on LinkedIn. And wow, I already forgot all of the social media accounts. But they also have a website. That's where all of the calls and everything will be announced. So do follow them and they will be able to share upcoming events as well as ways in which people can get involved. So I see a comment from Nina that says in our hackathon in Chile, there was even a challenge that many participants not only had not English as a first language, but also do speak only little English. So clearly this language thing is something that you will need to consider.
He actually managed to translate his challenge to Portuguese, I think, or Spanish. I can't remember.
Yeah. So we definitely need to look into how can we make it more accessible when we want it to be global. That means we have to also cater for all of the differences that come with it, especially the language thing.
And extra awards for those that don't speak English.
Well, I don't know if Kevin is committing to. I don't know if the OED is currently committing to giving extra awards for those who don't speak English, but yes, an extra awards for those who have to go through the whole process of translating the resources into a different language.
Yeah, in Spanish. Okay, in Spanish.
Yeah. There we go. Thank you so much, Nina, for the comment, as well as other issues that were like servers were offline at times. These are things that we have to deal with because, you know, technology is unpredictable and at some point things go wrong, but who knows, maybe the organizers found a way to work around
it
that.
makes it realistic. Sometimes you can't talk to the satellite. So, like, you know, if you can't talk to the server, then you're experiencing what we experience.
Yes, I'm sure there were many challenges, but also I think a lot was learned from the experience and a lot of skills were gained from this. So yeah, it's been a pleasure to just be part of this whole program and really looking forward to everything else you guys have in store for us. Yeah, so it basically brings us to the end of our program. Before we open it up to people who'd like to share anything or give us comments and stuff, I'd like for Charles Dagan, our deputy director. I feel like he was part of APHIS when Hack4dev was started, and then he moved on to the OED. So he just has like a lot of historical history as well about this. About Hack4dev. Spotlight him there. Yeah, so he can maybe close us off, and we can then open it up to everyone who has questions, comments, or would just like to share something for the next 18 minutes. But we're scheduled to finish at 16:30 South African time. So that's, I'm not going to do the other time zones because my brain is not going to do the math. Charles.
Firstly, hi everyone. Thank you for joining us. I think we sent out, invitations to a lot of people, and we are so excited to see most of them here. And for you all to now be part of this journey with us. When we started it just over 4 years ago, and Islam was not yet part of it, we didn't know that it was going to be something this big. Just a bunch of us sitting in the office saying we want to do something that, can have, real global impact, use the skills that we have in astronomy, use the skills from data science to make something great. And I think, we've been able to achieve this. And I think Islam, without you, without the team, would not have been able to then achieve all of this. I remember, just organizing all of this and putting it together last year, with Ram, getting even trying to get the, initially those that went and implemented the hackathons, getting them to South Africa, getting those funds out. It was a very huge task, and I think that we had a lot of patient people that were involved in the process, and I think that everyone owns this, from the people that were involved in those processes, from finance at SAO that helped us, to distribute all those funds. It was a very huge task. And I think Dara came in for us in a very big way, and we are really grateful for the collaboration that we have with Dara in implementing this. And yeah, and I just want to just use this moment to just be thankful and say, without people, there's nothing that we can do. It could be about the data science, can be about doing the science, doing astronomy, doing whatever we do. But without people, none of this can be meaningful. And I just want to thank everyone that's involved.
Thank you very much, Charles. And thank you so much to Emma for joining us from the Dara team. It's fantastic that you were able to see and be part of this event. But yeah, so if anyone would like to say anything or like share something, especially from the participants and those who are part of the team that feel like they have a burning comment that they like to share with everyone, now is your opportunity. But otherwise, those who have to leave now, you're more than welcome to. We've basically concluded this whole program, and yeah, thank you so much to everyone who joined us.
Let's see if there's any hands.
Yeah. Okay, just a lot of clapping. Yeah.
It feels like the pandemic all over again.
Well, thank you to everyone who came to the office. I mean, the office isn't going to be visible in a while, so yeah. But yeah, I think also just be on the lookout for the Hack4dev social media accounts. They'll be sharing updates on the winning team. The video that was played here will be online as well. Zodwa, we're looking at you because you've been a superstar with this. But yeah, thank you so much, everyone. Okay, I'm gonna say bye so everyone can start leaving.